Welcome to my class. I'm Drew Collip. In today's class, we're going to talk about linear equations. These are straight lines. Specifically, we're going to examine these linear equations when they're written in slope-intercept form. In a previous lecture, we learned about graphing linear equations, and we developed the formula y equals mx plus b. If you have a linear equation, this is when you have exponents of 1 on your variables x and y. This is going to be a straight line. If we solve for y, meaning isolate y on its own, we can just read off the coefficient in front of x, and this will be the slope of the line. We can read off the constant. This will be our y-intercept, or the coordinate 0b. This coordinate is your y-intercept, the spot where your line crosses the y-axis. Let's now examine this in closer detail. In example 1, it asks us to determine the slope and the y-intercept. You can see this equation here is already in slope-intercept form. Our y value is solved for. We look at the coefficient in front of our x. That is our slope. So slope is 2, meaning it's 2 rise over 1 run. We then look at the constant that's remaining, plus 1. This is our y-intercept. Your y-intercept will be 0, 1. This equation here is solved for y. Y is isolated on its own. Therefore, we can read off directly. We can read off the slope. We can read off your y-intercept. So slope is going to be minus 3 over 4. So minus 3 rise, 4 run, meaning it goes down 3 every time we move forward to the right 4 units. And our y-intercept is going to be 0, minus 5. I'd like you to try the last one here on your own. Notice this is not in slope-intercept form. This is in standard form. So your first step here will be to solve for y. Put y on one side and everything else on the other side. Once you have that, read off the slope and the y-intercept. Try that now. Let's take it up. Here we have 2y on this side. We move the 3x to the other side. It becomes minus 3x plus 6. Divide everything by 2. And our coefficient in front of the y cancels out. Here we get y is equal to minus 3 over 2x plus 3. So now we have it in slope-intercept form. What do we have here now? Our slope, minus 3 over 2. It goes down 3 every time we move to the right 2 units. And our y-intercept is going to be 0, positive 3. Just one additional step we had to do to convert this from standard form to slope-intercept form. Let's look at the next example. Find the slope and the y-intercept of this linear equation. Make a graph. So we could graph this and determine the slope, but we actually don't need to graph this at all to determine what the slope and the y-intercept is. So what we'll do is we will rearrange this from standard form into slope-intercept form. We will determine the slope and the y-intercept. We will plot the y-intercept and use the slope to find the other points. Let's try that now. 9x minus 3y equals 12. We want to isolate the 3y on its own, so we move the 9x to the other side, and we get that. We now want to isolate the y on its own, so divide everything by minus 3. And these will cancel out, leaving me y on its own. I've solved for y. Minus 9 divided by minus 3 is positive 3. And 12 divided by negative 3 is going to be minus 4. So here is our equation in slope-intercept form. Again, there's our slope. Here's our y-intercept. So slope is equal to 3, and your y-intercept is going to be 0, minus 4. Let's graph that now. Label my axes, x and y. Put my scale on here. I have to go to minus 4 as my y-intercept, so I want to make sure that that point will appear. Let's just do our standard 1 unit is 1 box. Make sure you label your axes. If you don't label your axes, it's being lazy. Make sure you label the entire x-axis and your entire y-axis. Let's plot that now. To start our line, we will plot the y-intercept on there. So 0 for my x-axis, I'm not moving off of the y-axis, and I move down to -4. Right there. To find the next line, I will then use my slope. Remember, this is 3 over 1. So slope is 3 over 1, 3 rise, 1 run. So I go up 3 every time I move right 1. So I go up 3, 1, 2, 3. I move over 1 right here. I then move up 3, 1, 2, 3, and over 1. And then do it again. 1, 2, 3, over 1. I have 4 points now. Looks like it's going to be a straight line. Let's connect the dots. And there you have it. So here we were given an equation in standard form. We first converted it to slope-intercept form. Using the y-intercept and the slope, we graphed it. We plotted the y-intercept first as our first point, and we used our slope to determine the other points on this graph. Let's see what happens when we have some unexpected slopes. So let's talk about vertical and horizontal lines. Let's first talk about a horizontal line. Here is my graph. And we will put a horizontal line on there. Put the line right here. Doesn't matter the scale. We're just using this as an example. So my slope is my rise over my run. Rise over run means my change in y over my change in x. Now, because this is a horizontal line, we can get a change in x. But what is our change in y? You can see this does not move horizontally at all. So there will be no change in your y. 0 divided by whatever the change in x is. There's nothing wrong with this expression here. This is just equal to 0. So slope is equal to 0 for a horizontal line. Let's say this was 8. We could actually get the formula for this. Our slope is 0, so y equals mx plus b. My slope is 0. Y is equal to b. What's b? B is my y-intercept. It's where it crosses the y-axis. So the equation for this line, y is equal to 8. You can see there is no slope. Slope is 0. Therefore, there is no x. So that's how you deal with horizontal lines. Let's now talk about vertical lines. Vertical line, again, doesn't really matter where it is. It's vertical. What is our slope now? Slope equals rise over run, which is my change in y over my change in x. Once again, there will be a change in y, but notice there's no movement left or right. There'll be no change in x. So this value will be 0. Try this with your calculator. Put any number in the numerator and divide by 0. See what you get. You get an error. This is undefined. Dividing a number by 0, you'll get undefined. So if you get an undefined slope, this is a vertical line. What would the equation for this look like? Y equals mx plus b. Before, when we had 0 as our slope, we just sub that in. But we can't do that here because undefined isn't a number. Let's say this is crossing at 6. What this equation would be is x is equal to 6. No matter what you do, x is always equal to 6. There is no y-intercept, there is no slope. So that's how you would graph x is equal to 6. These are two unique situations. When you have a horizontal line, there is no slope, it is 0. When you have a vertical line, there is also no slope, but it is undefined. Horizontal lines, y is equal to whatever the y-intercept is. Vertical lines, x is equal to whatever the x-intercept is. Let's now talk about writing the equation of a straight line. Up to this point, we've given you the equation, and we've either asked you to graph that equation or to pull out some information, let it be the slope, the y, or the x-intercept. Now we're going to go the opposite route. I'm going to give you information, and I want you to determine what the equation is, whether that information is your slope and your intercepts, or it is the graph itself. But here we want to write the equation. So what's the process? Step number 1, find the slope. Step number 2, find the y-intercept. Then substitute your m and your b into your y equals mx plus b equation. Let's now look at example 3. So write the equation of a linear equation, so it tells you it's a straight line, with a slope of 2 and a y-intercept of 3. Make a graph. Y equals mx plus b. This one's pretty easy. Our slope is 2 and our y-intercept is 3. So it's already given to you. Y equals 2x plus 3. Very simple. Again, this is our slope, 2 rise over 1 run, and this is my y-intercept. It has a coordinate 0, positive 3. Let's now graph it. Put our standard scale. 1 unit is 1 box. When we're graphing this, we'll put the y-intercept on there first. So it's crossing the y-axis at 0, 3, right there. Our slope is now 2. So we rise 2, we move over 1. We rise 2, we move over 1, right there. We can also go the other direction, -2, -1. 2 negatives make a positive. So these two things are equal. In this case, we go down 2 and back 1. Down 2, back 1. Down 2, back 1. We can get as many points as we want. Connect this with a straight line, and we are done. Let's now look at example 4. Find the linear equation that passes through these points. So all I've told you is that it's a straight line and it passes through these points. That's enough information to build this equation. So we want y equals mx plus b. Let's start by finding the slope. Slope, rise over run, which is equal to change in y over change in x, which is y2 minus y1 over x2 minus x1. Let's label these. I'll label this x1, y1, label this x2, y2. Once again, it doesn't matter which one I choose as point 1 and point 2, as long as you keep those numbers as an ordered pair and those numbers as an ordered pair, you'll get the same answer. Let's sub those values in. y2 is 6 minus y1, which is 2. This is over x2, which is 4. We subtract x1, which is 3. 6 minus 2 is 4. 4 minus 3 is 1. So our slope is 4. So I can sub that in right here. Y equals 4x plus b. Now I have to find out what b is. How do we do that now? You can see here I have 1, 2, 3 unknowns. In order to solve for b, I just have to find a situation where I know both y and x. And it's important that when I sub in x and y, these are ordered pairs. We have a choice here. We can either sub in these values or these values. It doesn't matter. I will sub in the first set. Sub in 3, 2. Let's substitute that in now. So this is going to be 2 is y is equal to 4 times 3 plus b. So I'm trying to color code this for you. You can see the 4 came from over here. And the 2 and the 3 come from the coordinate. Let's now solve that. 2 is equal to 12 plus b. Swing the 12 over to the other side. 2 minus 12 equals b. So b is equal to minus 10. Now we can finalize this and build that equation. Y equals 4x minus 10. Final answer. Because we know it's a straight line, all we need is 2 points. From that, we can calculate everything else. Let's look at another example. With this one, we're looking for the linear equation that passes through this point and this y-intercept. So similar, except it looks like we were only given one point and just the y-intercept. But please note, this is actually a point as well. This is the point 0, -4. So we can solve this the same way. Slope is equal to y2 minus y1 over x2 minus x1. Make sure we don't mess those up. This is x1, this is y1, this is x2, this is y2. Let's sub those values in. y2 is -4, y1 is 4, so we're taking that away. We then sub in x2. x2 is 0, and we're subtracting -12. This will give me a positive number. -8 minus -12 is +12. This gives me a value simplified down to -2/3. Using our formula, y equals mx plus b, we can substitute in our slope for m, 2/3x plus b. What we now want to do is solve for b. I need to sub in something for x and y. Let's sub in our point -12, 4. We substitute that in now. 4 goes in here, -12 over there. And we solve this. 4 equals -2 times 12 is going to be +24/3 plus b. Swing that over to the other side, becomes -24 divided by 3 is 8. b is equal to -4. So y equals -2/3x minus 4. Final answer. There's actually an alternative way to solve this. Let me show you that now. What we did previously is we solved for m, sub that in, and then solve for b. Let's go the other route. Let's solve for b first. We know what b is. It's right here. Let's substitute that in here. Y equals mx minus 4. Now you can see we have 3 unknowns. Let's sub in -12, 4 into x and y, and we'll solve for m in this case. We get 4 is equal to m times -12 minus 4. 4 equals -12m minus 4. Swing the 4 to the other side, becomes 8 equals -12m, and then divide both sides by -12 to isolate the m on its own. These cancel out, and I'm left with my slope being equal to -8/12, which is the same as saying -2/3. So right here, 2 alternative ways to solve this one problem. We can either determine the slope first and then solve for the y-intercept, or if we're given the y-intercept, we can just sub that in and then finally solve for the slope. We talked about horizontal lines. Let's work this one out right now. Find the equation of the horizontal line that passes through this point. So a horizontal line and it passes through the point 3, 2. And it passes through the point 3 and 2. So it goes right here. And what does it say? It's a horizontal line. So I can graph that first. There you go. There's what the graph looks like. What is the equation, however? Y equals mx plus b. It has a y-intercept. It's crossing at 2. So y equals mx plus 2. What is my slope? Well, slope is rise over run. This will have a run, but it will not have a slope. Therefore, your slope is 0. We sub that in. Y is equal to 0 times x plus 2. So the equation of a horizontal line, y is equal to 2. That is it. Notice we are just using that point right there. Y is equal to 2. It's always equal to 2. Never changes. we looked at a horizontal line. Now let's look at a vertical line that passes through this point right here. Sometimes it's easier to graph this first to get an idea of what you're looking at. X and Y. And this passes through the point 3, 2. And we say this is a vertical line. So this will look just like that. Y equals mx plus b. What is my y-intercept? It doesn't have a y-intercept. It never crosses the y-axis, so that's out. Y is equal to mx. What's my slope? Slope is rise over run. There will be a rise, but there will not be a run. This is undefined. So we can't figure out the y-intercept. We also can't figure out the slope. So what is the equation here? The equation here is simply x is equal to 3. Again, we're just looking to that point right there. There are now a large number of practice problems. Practice 1, find the slope in the line. Practice 2, draw the line. Practice 3, graph the equation. 4, write the equation of the line. And 5, find the equation in slope-intercept form. So give these a try. I won't be taking any of these up, but I have the answers at the bottom right here. I didn't do the answers for 2 because that's a bunch of graphs. But we have 1, 3, 4, and 5. I gave these all a try. Pretty sure they're all correct. If you have any problems with those, feel free to ask me during tutorial or contact me outside of class. So in today's lecture, we built on what we learned in our previous lecture about graphing linear equations. Previously, we learned about using a table of values and using our x and y intercept as our 2 points. When we know y equals mx plus b, we understand that the coefficient on our x variable is the slope, and we understand that the constant is your y-intercept. Using these 2 pieces of information, we can quickly make the equation, and we can quickly graph it by using the y-intercept as our starting point and using the slope to find all the additional points. In our next lecture, we'll be looking at systems of linear equations, looking at more than one linear equation at a time. So it's very important you fully understand these concepts before we go to the next level. That's all for today. Until next time.